So I guess by a show of hands, how many of you have heard of EGFR? Probably mostly everybody, right? What about like KRAS? Right, mostly everybody. What about a gene called LKB1? Few people, right? Few people. So it turns out that LKB1 also goes by another name called STK11. Turns out LKB1 is mutating 20 to 30% of lung adenocarcinomas. Okay, 20-30% is the second highest mutated tumor suppressor gene, next to P53, which you've probably heard of as well. So if you look at the number of publications on P53, it's like 70,000. In lung cancer, it's like 8,000. If you look at LKB1 in lung cancer, right, where it's mutated, 20 to 30% of patients, it's somewhere along the lines of about 400, 300 papers, and most of them have just sort of hit recently. So this is something that, based upon our estimates in the United States, estimated 30 to 40,000 lung adenocarcinoma patients that have this mutation, and we have absolutely no targeted treatment for this. Okay? What makes it worse is that it's co-mutated usually with KRAS. So KRAS is notorious, right? There's consortiums that are focused on targeting RAS. We've been trying to target RAS not just in lung cancer, but in all cancers. It essentially has been untargetable. Everything we try to do is failed. So what we've been working on in the lab specifically is looking at this KRAS LKB1 co-mutation because it occurs in patients. And essentially what we see, if we just look in the databases, sequencing databases, patients that have the co-mutation do worse than if you have either alone, okay, or if you have some other types of mutations, such as EGFR and so forth, because we have no treatment. We have absolutely no targeted treatment for these patients. So there's a huge, huge group of patients that we need to address. And this is one of the primary directions that the lab is going in right now. Okay, so I want to talk a little bit about what we're trying to do, but I also kind of wanted to, and where we're going with that. So just kind of just hold that thought for a second. I kind of wanted to just give you a little bit of background. Kind of people always ask, how did you get to be a researcher and those sorts of things, and how does it go there? And I kind of want to lead up to how we came to this LKB1 story. So I spoke to a lot of people here. I grew up in New York City. Basically, my whole life was not actually really that much science. I actually grew up playing tennis pretty much my whole life. That was what I did. I went to a high school in New York City. Had like 5,000 students in there, so it was huge. And basically, I was in a special math and science program. So that was where I got exposed to some of the biology and things like that. And then I went through college, and then essentially you go to apply to graduate school for PhD. I applied to Penn State, and I'm sitting in a group of basically 10 other applicants, and they're telling me these stories, about how they're working on this research, that research, etc. How they're trying to cure all this, and again, pretty much all I did was play tennis. So that was going in, and at every meeting where I actually met with the faculty, they kept saying, you're all American tennis player, so this, and I'm convinced that was the only reason why I really got accepted to graduate school. However, if you look at the class I got taken in, there was about 6 of us. I was the first one to graduate, and I was only one other person that actually went on to academia. So there's something to be said about, having diverse backgrounds, something to be said about, sports in general and competition. I think it's actually quite important, and it still motivates me today. So if we fast forward a little bit, I basically then went to Emory to do my fellowship. That was about, let's say, 15 years ago. So I did my fellowship, and that was for about 3 years. And then I started up as assistant professor in about, 2005. So when I started up, we actually looked at this gene LKB1. Back then, there was nothing known about it. What was known was that what we call is it's well conserved. So what that means is that yeast have it, flies have it, carrots have it, different forms of it, dogs have it, cats have it, humans have it. So it's a well conserved gene, and a lot of people were very interested in it. But we had no clue about this mutation rate. But we actually looked at it, and the first thing we saw when we looked at it was that, under the microscope, it was that basically this protein was always at the front So it wasn't behind, it wasn't in like the nucleus of the cell, it wasn't just spread everywhere. It always accumulated on the front. So this idea sort of intrigued us a lot, and that was when we actually applied for funding for Free to Breathe, or National Lung Cancer Partnership at the time. And we applied on our first try, and it's one of those things where you get the score, you get the review, and you basically look at it and you say, this can't be me, so you close it, then you open it back up, and then you realize that the actual score was good, and you're most likely going to be awarded this. So that was basically in 2008 or so. Yeah, so the slides from yesterday reminded me that was about 8 years ago. So we basically started our research on there from the National Lung Cancer Partnership. About a year or two later, we actually, right when that award was ending, we actually got funding from American Cancer Society as well, also related to that. And then basically we worked on this for a long time, and while this was going on, this was when all the information came out that this gene was highly mutated. So this came out, I'm going to say, somewhere around like 2010 or 11 or something like that. And again, that mutation rate was staggering. It was on nobody's radar. I mean, just to have something so highly mutated, it was on nobody's radar. And I still say that actually today it pales in comparison to, I was just seeing one of the breakout sessions on there. It had KRAS, it had PD-L1, etc., ALK-ROS. But there's still so little on it. If you go look at AACR, which is the big cancer research meeting, and you look at abstracts and type in LKB1, there's about 5 abstracts, and like 4 of them are from our laboratory. So it just staggers me that there aren't more people working on it. I'd say there's about 9 or 10 groups in the United States that work on it, and several overseas. So all of a sudden we got thrown into this world of clinical cancer research because of this high mutation rate. And LKB1 did move a little bit more into the spotlight, and we were now part of this, basically this big game to understand what this is doing in cancer patients. And keep in mind, when I went for my PhD, I actually went in biology. I actually studied plants. So my background was plant biology. So I was not a botanist, so everyone thinks I'm a botanist and then sort of get gardening questions. But I really actually used, it was like a sore subject for me. We used plants as our model system to study cell growth, is what I always say. But everyone thinks it's botany. So all of a sudden I was, I don't want to say doing clinical research, but doing something that really could make a difference and really could impact patients. So this is all going on between like 2009 to maybe like 2013, 2012, and there are several new publications coming out. Some mouse models were made for this to actually study it and reproduce some of the things that go on in the patients by our group as well as others. And we realized that at this point, we're starting to learn how it actually works, but we realized we really needed to get serious to understand how can we help patients at this time. Again, going back to the idea that there's really no targeted treatments for this. So this was when, I'd say about 2 years ago, we actually applied for 2 R01 grants, which is from the NIH, which is basically the standard sort of funding. And these were different grants because they weren't called multiple investigator grants. These are team grants, basically. And in my opinion, and we've heard a little bit about it as well, is that this team science is key. So there are things, I can never propose a clinical trial on my grant unless I have a physician. I can never propose to do sequencing unless I have a genomicist, a pathologist, a biostatistician on there. So these grants are actually getting bigger and bigger in terms of people on there. So we applied for these, actually 2 team grants. One of them was a $2 million in fund R01. Most R01s are about $1.25 million. We applied for more because there was about 10 of us on this grant. And basically these studies were expensive. And the purpose of that, the whole purpose of that grant was a very simple idea, was that how do we treat LKB1 KRAS patients? And we were going to use mouse models to do it. And then the other grant was also looking at, was a standard R1, but actually in collaboration with an investigator that studies LKB1 neutralized in Drosophila. So we go in on this larger R01 first, and lo and behold, we actually got it on our first try. And we ended up being awarded this grant. It was again one of those things where basically, you know, we had a giant group hug and we were shocked to see the score. So you know, I mean, you know, you sort of feel it has to be a mistake when you see the number pop up on there. And all the investigators here know that like fear in your heart when you click the button and you know you wait to see what the score is, or the two worst letters you could see are ND, which means not discussed, which means you basically put in all your effort, and while the grant was reviewed, it was not discussed among the panel. So that causes your heart to drop considering how much work goes into it. But we got a good score, and you know we ended up being funded, and then on the other one that used a combination of flies and mouse models also got funded. So from that initial $100,000, I'd say now we're somewhere well over $3 million on funding for LKB1 research, and again trying to help patients. So we have that going on, and also what it's actually brought together, and I think actually this is the biggest part, and we're going back in for funding. We're having a very, very large, what we call program project grant, which is actually like 3 or 4 of those R1s combined. And the whole grant is actually focused on LKB1. So the actual team that we have there are clinicians that some of you in the Atlanta area may know, like Suresh Ramalingam, who's a lung oncologist. We have a pharmacologist, Diane Fu, who runs a drug screening facility. We have pathologists, geneticists, biostatisticians, nurse coordinators, people who consent to patients. But the key of this grant, which is going to go back in, is that we're going to run a clinical trial. So this is like the culmination of everything we've been trying to do. We're going to run a trial that's going to be specifically targeted at KRAS LKB1 patients. The data for this trial stems from several years of work, because the first thing we have to be able to do is detect that LKB1 mutation. If we can't detect the mutation, we don't know if these are KRAS LKB1 mutant patients, obviously. So doing that took about 3 years to actually set up, and you hear about why things take so long. Lots of logistics, getting someone to consent to the patient, getting the tissue to the pathologist, getting the pathologist to read it, then getting the tissue to the lab, and so on. So on that grant, we're able to sequence, and we're also running, to our knowledge, one of the first trials, I think the first trial, that specifically separates out KRAS LKB1 combination patients. And this is based upon a lot of the data that we generated in the mouse model, as well as actually other labs have very similar data looking at this. So we're specifically going to try and target these patients. Obviously, we don't know if it's going to work or not. But I feel like, coming from a very basic science background, I feel like this is really like one major sort of stage of the work that we're trying to do, and just knowing that at least we're giving it a try, I feel like providing some level of hope for these patients is really, really important. To me, really important to the lab, and I think it's really important to the greater lung cancer community as well. So I think I just want to echo a little bit, and I'll finish up, and if you have questions, I just want to echo a little bit of what Joan was saying earlier on. I feel like everything we talked about, all these ideas, all these big promises, all this hope, really, really lies in research. Obviously, I'm biased here, right, because I'm a researcher, but things like this do not happen, magically. This requires blood, sweat, tears, money to get these things done. There are people every day working on this, and I feel like getting more research out there, getting researchers speak about what they do, getting researchers to open their doors, like we saw in the videos, show people what goes on is really, really important. So I truly believe that all hope lives in research, and I really, again, just want to thank you for everything that you do to make that happen.